Okay, let's start 7-8, which is about multiplying polynomials. This is part 1. We'll be doing this for a few days because there's so many different parts to this one lesson. Let's start with example 1, which is multiplying monomials. So as you can see, this term and this term, they're not separated by an addition or a subtraction sign. Because it's straight multiplication, I can multiply them all together. So if I were to separate it out, it would be 6 times y cubed times 3 times y to the 5th. Okay, all I did was put in the multiplicative dot between each piece of the monomials. 6 and 3 are like terms and they combine to 18. Y cubed and y to the 5th. Remember, when we multiply with the same base, we add the exponents. So the end answer would be 18y to the 8th. From the beginning, what that means you can do is take each piece right away. 6 times 3 is 18. This is a y, this is a y. You end up with y to the 3 plus 5, which is 8. Okay, you can do it either way. You'll get the same answer. For letter B, we have 3mn squared times 9m squared n. There's no addition, there's no subtraction, it's straight multiplication. So we can multiply each piece. We have 3 times 9, m with another m, and n with another n. 3 times 9 gives me 27. M, this is like m to the first, so m to the 1 with another m squared is 1 plus 2. And then we have n, 2 plus 1. The end answer would be 27, m to the third, and n to the 2 plus 1 to the third. So 27m cubed n cubed. All you're doing is multiplying each piece that's the same. So the base of y is the same. The exponents are not the same. If this had been y to the third plus y to the 5th, okay, there's nothing you could do. That would be simplified. But because it's multiplication, we get to use our exponent rules. And our exponents rules say we add the exponents, keep the base. Okay, that's where it came from. It's all related. Let's try example C. Now this time we have 3 different parentheses. We have 3 different monomials being multiplied together. So I have a 1/4. I don't have a coefficient here. Well, it's 1. I can't see it. And a negative 12. Notice that it's negative 12. It is not minus 12xy squared with these parentheses. Okay, it's multiplication. So 1/4 times a negative 12, that would get me my coefficient. Remember, when you multiply a fraction by a number, this case an integer, you multiply across, so that would be negative 12/4, which is negative 3. Now I have an x squared with an x and another x, so that's x to the 2 plus 1 plus 1. Then we have the y squared, y to the first, and another y squared. I'm going to simplify the exponents. I get negative 3x to the 2 plus 1 plus 1, that's 4, and y to the 2 plus 1 plus 2 is 5. The answer when all of this gets simplified is negative 3x to the 4th, y to the 5th. Let's try multiplying a polynomial by a monomial. In this case, the monomial is just a 4. 4 outside of parentheses if we had x minus 2. Since x and 2 can't be combined, they're not like terms, we would distribute that 4 to both pieces. We're going to do the same thing now, except now it's a trinomial. It's a quadratic trinomial. That 4 gets multiplied by each part. So this piece, and this piece. There's 3 pieces that get multiplied by 4. 4 times a 3x squared plus 4 times a 4x minus a 4 times 8. Okay, that's where that subtraction sign goes. I didn't get rid of it. 4 times 3, I can combine coefficients to make 12x squared, plus 4 times 4 gives me 16x, minus 4 times 8 is 32. Now I'm going to check just to make sure. This is an x squared, this is an x, and this is a number, a constant. There's no like terms, there's nothing to simplify. This is my answer. 12x squared plus 16x minus 32. Now in example B, I have 6pq times 2p minus q. So this whole piece gets multiplied by 2p and gets multiplied by a minus q. So I have 6pq times 2p minus, okay, that's where it went, 6pq times q. So again, in case this is confusing, 2p, 2p, q, and q. Okay? It gets multiplied by both terms. Now let's combine what we can. 6 times 2 is 12. I have a p and another p, that gives me p squared. And then q is all by itself, q. Minus 6, there's no other constants or coefficients, so that's just 6. There's no other p, and I have 2 q's, so q squared. 12p squared q minus 6pq squared. These are not like terms. This has a coefficient, has an exponent of 2, and here it's a 1. This has an exponent of 1, this has an exponent of 2. They are not like terms, therefore, that is the answer. There's nothing else to simplify. Let's try one more, and I know this one is a little bit more complicated. Each time it gets a little bit harder. This whole part gets multiplied by a 6xy and an 8x squared y squared. So we have a 1/2 x squared y times 6xy plus, okay, there's the plus sign, 1/2 x squared y times 8x squared y squared. I'm going to look for anything that I can combine. 1/2 times 6 gives me 3. I have an x squared with another x to the first. That gives me x to the 2 plus 1. And y, I have a y to the first and another y to the first. That's y squared. Okay, there's 3 pieces. Plus 1/2 times 8 is 4. I have an x squared and another x squared. That's x to the 2 plus 2. And y with an exponent of 1 and y with an exponent of 2, 1 plus 2. Let's simplify our exponents. 3x cubed y squared plus 4x to the 4th y cubed. These are not the same exponents, 3 and 4, 2 and 2, so I cannot combine them. They are not like terms. That is the answer. 3x cubed y squared plus 4x to the 4th y cubed. It's your turn. In order to type the exponents, you use the little caret. So this would be x to the 5th. Okay, they mean the same thing. You'll use the little caret on the keyboard, and that will tell me that that next number is in the exponent. I want you to check it out, 1a, 1b, 1c, and 2a, 2b, 2c. The check it out start on page 446 in your book. Okay, don't forget to answer the Google form. Good job, everyone. I'll see you tomorrow. Good night.